Good morning. My name is Arun Gupta, and I am a principal open source technologist for Amazon.
I'm Sarah Wells. I'm Technical Director for Operations Reliability at the Financial Times.
Microservices is all the rage these days, and customers are using containers to deploy that architecture pattern in their applications. Today, we'll talk about how you can use AWS to build your microservices using containers, and then we'll hear from Financial Times how they have been using this as a platform for going into production. Let's take a look back at development in Amazon. This is back in 2001 timeframe. Now, we had a monolithic architecture at that point of time, like everybody else around that time. And that means if you want to change one thing in the application, the entire application has to be changed. Think about, you are driving a car and you want to change the wheel of the car, but you want to get a brand new car. There is no option for changing the wheel only. I like shiny new cars, but that is an expensive proposition, which my family would not approve, and that's an unnecessary maintenance hazard for me as well. So one of the problems that we realized at Amazon is a lot of people were setting up their own infrastructure, and that was taking such a long time for them to introduce a new feature into the application. So back in 2006, Andy Jassy started a proposal that, hey, we should propose data center as a utility to our customers, first of all internal and then to external. And that's how essentially AWS was started. Then we started realizing, these services that are being used all across Amazon, we started creating them as services that could potentially be used internally and then externally. So we started with SQS, S3, so on and so forth. And today we have about 120 plus services that customers have access to. So essentially, Amazon.com architecture changed from one big monolithic application with multiple service teams working on it to multiple teams collaborating on services, and then those services really working with each other. Each team was really a two-pizza team. Now, you may think American-sized pizza or a European-sized pizza. Opinions could differ. Or you may think, hey, there's this guy who eats 4 slices as opposed to 2 slices. But that's not what a two-pizza team is about. Two-pizza team is really about full autonomy. It's a single-threaded discussion. You build the product, you run the product. You are creating a microservice that is working for you. You have full accountability of it. You have the full ability to change any underlying implementation of it. You perform the DevOps model where you build it, you run it, you break it, you fix it, and you move on with it. Now, earlier this year, I tweeted that customers think that monolithics are really bad, and microservices is a golden hammer that can solve all of my issues. So I want to put a disclaimer over there. Think about what is the business problem that you're trying to solve. You're trying to innovate for your customer. You're trying to bring agility in your application development process. That is what matters. If you're able to do that with monolithic, sure. But we're seeing a lot more customers going onto the microservices route, and that's where this session is absolutely relevant for you. Now, if you are on the microservices route, there are changes that need to be made. What we talked about is just Amazon's history so far on how we have gone from monolithic to microservices-based architecture, and hundreds and thousands of customers have done that. And of course, Amazon has helped a lot of them as well. But what kind of changes are required in order to onboard on that journey? Well, you need changes in your architectural patterns, you need changes in your operational model, and you need changes in how you deliver software. Let's talk about them one by one. The first one is changes to architectural patterns. Now, if you look at monoliths, they are good. They serve a purpose. They've been not broken, don't fix it kind of paradigm. They work first. They work fine. And typically, the thought process is the monoliths are simple at first, but as the complexity of the application grows, as members get to the team, members move to a different team, the complexity of the application grows. And there is an additional coordination overhead that needs to be done to maintain that monolith. Also, the code related to similar functions starts to become copy-paste across different parts of the application because there is no concept of dry. You're not really don't repeat yourself, but you're really copy-pasting the code because you want to get that functionality up and running. All or nothing really could lead to downtime and a high impact of change for the application, because one change can bring the entire application down, and that leads to a bad customer experience. You don't want to go that route. Different parts of the application have different scaling requirements. Could be CPU, could be network, could be disk. But because it's a monolithic application and the requirements have to be met for the entire application, you always end up over-provisioning so that the monolithic application can be scaled accordingly. That's an inefficient utilization of resources. And last but not the least, you have a much longer build time. A single change means you have to build the entire application, and that's not really agile. So what we are looking at is taking that monolithic application, one big monolithic application, and breaking it down into smaller functionalities. And those functionalities are called as microservices. And then they are interacting with each other to create the same business experience. In a monolithic world, you really have a shared release pipeline where all the developers are pushing their change through that shared release pipeline. And because it requires coordination, and sometimes coordination breaks, it can cause friction in the pipeline. You want to upgrade a shared library. You want to leverage the new feature that has been recently introduced in version 1.1. Well, the other team does not want to use that feature, so good luck with kind of figuring out how you can upgrade the shared library. There are concepts like merge Fridays, where everybody building that application is going to sit together on Friday so that they can actually agree upon what the merge is going to look like and what's the version of the libraries they're going to use. Even though you want to push a single change to your application, you need to rebuild, retest everything. For a fast growth company trying to innovate and compete, this overhead and sluggishness is completely unacceptable. Let's switch gears on how microservices really help you on that. Well, of course, you have many smaller minimal function microservices that are working with each other to create the same business experience for yourself. Each microservice can deploy independently. Each has its own data store. They're all organized around business capabilities. What you're getting is your system boundary is your business boundary. So you identify the scope of the microservice, and you focus on that part of it. Also, the ability, because your focus is very small, you can innovate a lot more rapidly. You can continue to iterate the application a lot more rapidly, and you can continue to push changes a lot more rapidly as well. Now, because we are taking one big application and breaking it down into multiple smaller applications, integration becomes a top priority. And getting integration right is absolutely critical. Well, first of all, you need to avoid breaking changes. The whole point of a microservice is being able to make a change to one service and deploy it, and yet keep the business logic up and going. So you want to make sure there are no breaking changes over there. You also want to make sure your APIs are technology agnostic. You don't want to use an API or a product which allows APIs to interact, where the product defines what stack is going to be used in your application. So think about, you don't want to use enterprise service buses as opposed to HTTP REST API, which is very stateless. There is also a very low coupling between the different microservices. All communication between services happens using network calls, and it basically enforces separation between the API versus the underlying implementation. All the implementation detail is completely hidden from the end user or from the consumer of the microservice, which gives you the flexibility that you can change your implementation detail rather quickly. So essentially what you're looking at is, in case of your microservices, you can look at Amazon API Gateway, which is a fully managed service on how that could be the forefront of your APIs. It allows you to do metering. It allows you to do rate limiting. It allows you to set up your HTTP REST API gateways, and all of that together. You can start doing caching of your APIs. You can start scaling the API accordingly if you need to. If you need a private backend, then Amazon API supports private link integrations. If you need a private API, you also have your own VPC in which you can easily set up that this API can only be invoked from within the VPC. The way microservices world looks like, essentially it becomes very event-driven architecture. Now you have multiple microservices sitting around, and they're waiting for an event to occur. An event occurs, You call the microservices. The microservice is essentially stateless. You get a response back, and then you move on. How do you handle that asynchronous communication? You could do synchronous communication as well, but the asynchrony is what gives you the scalability part of it. So of course, within AWS, we have a variety of services to help you with that. You can use simple queuing service or simple notification service. And the advantage of using that is it gives you the ability, it decouples the producer and the consumer of the service. The producer does not know how the consumer is going to consume it, but they have agreed upon the payload of the service. Now, we have lots of microservices that are really talking to each other. How do we track state between all these things? How do we make sure that they are getting executed in the right order? We need a state machine to maintain that. So it's important to build a workflow which can orchestrate all of your state of the application, which can define that microservice A calls B, and based upon a decision within B, you can call C or D. This also helps you understand if there are any redundant microservices that you need to get rid of. You can start setting timeouts on tasks. You can interrupt the execution. You can have tasks send heartbeats. And all of that should be able to be done from within your workflow, essentially. Let's take a look at it, how AWS provides a complete cloud for you to create containerized microservices. Compute is a key part on how you build those microservices. 4 years ago at re:Invent, we launched Amazon ECS. That is a fully managed container orchestration platform that you can run on Amazon. Today, we are launching hundreds of millions of containers on ECS every week. Last year, we launched Amazon EKS, or Elastic Container Service, for Kubernetes. That gives you a managed Kubernetes control plane. So you can easily get started with the Kubernetes cluster, go to AWS console, create a Kubernetes control plane, attach the worker nodes, and you have your full Kubernetes cluster over there. Compute is just one part of microservices. But if you start looking at sort of the broader spectrum, you need storage and database. So you need tools like relational databases. We have Amazon RDS, which provides you a single interface to a variety of different databases in the backend. So Oracle, MySQL, Postgres, Aurora, name a database, and that's integrated as part of RDS. You're looking at non-relational database, then we have Amazon DynamoDB that gives you full multi-region, multi-master database in a managed service way. We talked about the importance of integration. So how microservices are really collaborating with each other using an asynchronous mechanism. And we talked about SQS, SNS, and other tools, and step functions particularly to orchestrate your microservices together. We talked about the importance of Amazon API Gateway, how that could be the front end for your applications, and how you can start exposing your Lambda functions if you're writing them as microservices, or even containers at the back end, and create an API Gateway front end for your containers. It's not just about building and deploying the microservices. You also need to write correct tools in order to deploy those microservices. The velocity of change is very important. And if you want that velocity of change, then you really need to automate that process. And that's where exactly tools like code build, code commit, code pipeline really help. Fully managed deployment pipelines that you can easily get started with on AWS. And last but not the least, you need a complete set of logging and monitoring tools. If you're using containers, there are a lot of tools available in the open source world that you can integrate with. But we, of course, within AWS, we have tools like AWS X-Ray, which provides you distributed end-to-end tracing, for example, in Kubernetes. And particularly in a container land, your microservices could be written in multiple languages. But if there is a problem happening somewhere in the flow, from your front end to your microservices to your database, AWS X-Ray provides you complete end-to-end heat map for how the application is looking. This helps you identify bottlenecks and then debug them from there. Now, 8 reasons why Amazon uses microservices. First of all, one size does not fit all. So with Monolith, you are forced to select the lowest common denominator. With microservices, because your scope is small, because you are doing a focused innovation, you can pick the right tool for the right job. So if today Node happens to be the right language for you, you can continue to use it. But if tomorrow Go happens to be the right language for you, you can switch your platform as long as you're honoring the contract of the API. Werner Vogels wrote a paper on the 10th anniversary of AWS, and he talked about how failures are a given, and everything will eventually fail over time. We need to keep the system running, even if the house is on fire. So the important part here is you want to make sure you embrace the failure. You cannot close your eyes and say the failure is not coming. The failure is going to happen. It's about how quickly you recover from it. And because, as opposed to a one big monolithic application, if a failure happens, the entire application goes down. With microservice, if it's just one part of the application goes down, you should still be able to recover from it and recover gracefully. As we looked at the monolithic application, it really over-provisions your resources. And what that means is, it's not very efficient for you. But with microservices, you can do lower cost with granular scaling. So for example, one part of your application is just the front end, and you can right-size your EC2 instance accordingly. And the other point needs to be more optimized for an operational workflow, and then you can right-size the instance. Because of the coordination overhead in monoliths, it tends to become bulky rather soon. In microservices, because the focus is small and you're focusing on the two-piece team aspect of it, it really allows you to optimize on the team productivity. You can start using tools which really allows you to communicate a lot more collaboratively, and the team size is much smaller as well. When you typically go on a microservices journey, you tend to kind of sometimes over-microsize your application. You may think that I have too much granularity in the application, but your end users may not really need that granularity. So in that case, you can start creating new compositions that can then be used by your end users. And it really allows you to create those compositions quickly, because end of the day, you're looking at really workflows and expose that workflow as a microservice itself. It also gives you the ability to experiment and fail safely, because again, if it fails, it's only one part of the application. But in case of a monolithic application, if the thing fails, the entire application goes down, which is, again, not the customer experience that you would like to have. With a monolithic application, you are doing the entire language stack framework for your application. And changing that to adapt to a newer technology could be much harder. I've been a Java developer pretty much all my life. If you start with a J2EE or Java EE framework and Spring Boot comes along, then it makes it that much harder for you to change that framework. But if you are using a microservices-based approach, this would allow you to make that switch rather gradually, because all you're doing is you're honoring the API contract that matters to your customers. And last but not the least, because you're able to iterate more rapidly, you're able to go through the deployment pipelines a lot more rapidly, you can deploy features more quickly as well. So let's take a look at it. What are the changes required in your operational model? We have always talked about shared responsibility. What that means is AWS operates, manages, provisions the infrastructure for you, and is responsible for the security, including to the data center level. As customers build applications on top of that, they're responsible for the security of their application, and we provide the right tools for it. That's sort of the shared responsibility model that we've always talked about. Now, depending upon where you are in your microservices journey, you could choose, for example, the compute using EC2 instances, but then you may realize, for databases, I really want a DynamoDB. So really, there is no hard line over here on what you want to choose in terms of responsibility, but we have right tools, right privileges, right services for you to get started with very easily and figure out what really works for you best, and then accordingly pick the right tool. So digging a little bit deeper on the operational responsibility model, if we look particularly at the compute aspect of it, we look at it, EC2 is the basic compute primitive. Then, of course, we have ECS and EKS. Both of those are very strategic services for Amazon. You can use container management as a service over there. Then, of course, if you are not even worried about what is my underlying orchestration system, as an app developer, that is undifferentiated heavy lifting for me, and I'm all in on AWS. all I want is build my container and somebody else to manage that container for me, then you can go to AWS Fargate route. Today, AWS Fargate is only available for ECS, though. And then last but not the least, if you don't even want to create a container, you just want to create a functionality and run that functionality up in the cloud, somebody else manages that for you, then of course you can use AWS Lambda. And if you heard the keynote yesterday of Peter DeSantis, you probably heard Matt Wood talking about how we are running trillions of transactions on AWS Lambda every month. Let's dig a little bit deeper into the containers and microservices part of the LAN, and how they are really closely correlated with each other. Well, the containers do one thing and one thing really well. If you look at a Docker file, for example, which is how you create a container, it could have multiple CMD commands. But only the last CMD command is the one that becomes active. That means container do only one thing. And that matches very well with the domain-driven design for your microservices. Containers, again, make you completely agnostic of what application, what language, what framework you're using. And that, again, nicely complements on how that could be done for microservices. It also removes the impedance mismatch between your test, staging, development, deployment, artifacts. And that's really important, particularly if you have a high cadence or high release velocity for your features. The services are fully contained. There are no external dependencies. And that's exactly what happens with Docker, because everything needs to be packaged into the Docker image itself. Because of C groups and namespaces, containers provides that isolated execution environment. And this is very relevant from the microservices perspective because it helps you reduce the blast radius, essentially. Containers start up a lot more rapidly as opposed to a virtual machine. And again, nicely complements because you may be scaling your services up and down rather rapidly. And then on scaling and upgrading particularly, most of the container orchestration frameworks provides native primitives which allow you to scale your service up and down. And that becomes very essential in a microservices world. So the first question that often comes up is, because there is so much complexity around it, how do we manage that complexity in terms of these microservices? How do we get more visibility into my metrics, my logging, my monitoring aspect of these microservices? Now, if you're building microservices, if you're getting that polyglot approach over there, then you can start looking at putting the monitoring, the routing, the discovery logic, all of that as part of your application. But we talked about the polyglot approach. What that means is, if you're using Java and Node and Go, it causes a framework explosion. You need to manage those dependencies and need to make sure that those dependencies are going to continue to maintain over a period of time. It becomes a nightmare very soon, rather. So the approach that we have seen customers using is they're going to keep the application code separate, but move those cross-cutting concerns, monitoring, routing, discovery, deployment, et cetera, into a proxy. So one of the popular approaches that we have seen customers using is, say, using Envoy as a proxy, because that handles all of those concerns very easily. Now, Envoy is a CNCF project, which was created by Lyft and can handle up to 2 million concurrent transactions per second. So it's known to scale really well. What that gives you is the ability to get more observability and traffic control for your applications. So you can start doing features like A/B testing or canary testing. Now, you want to introduce a new version of your application very easily. From the client side, you can guide where the traffic needs to go. You start getting distributed tracing across multiple applications, multiple microservices, across multiple languages, and that's the beauty of it. And most importantly, it works across multiple clusters, across container technologies, and it avoids the framework explosion for you, so it's a lot more maintainable. Let's take a look at our simple application here. I have a web application that talks to a shopping cart, that talks to inventory in the backend, and also a notification on the side. The shopping cart, the inventory, and the notifications are written in different languages, so that's a true microservices architecture here. Now, I can introduce a chaos in my application. I want to test how my application is going to behave if I go from web to shopping cart. So for example, I can introduce some latency and see how my application is going to react. That's an important aspect of your testing. Now, from shopping cart to inventory, I can set up how many times a retry needs to be done. So you can set up the retries, and you can say, this needs to be done outside the application logic, independent of the language. Now, you are running version 1.0 of the inventory application, which was built using Ruby, and you decide that I'm going to launch version 1.1 that is written using Go. And I'm going to introduce that new service, but from client side, I can start doing traffic shifting. That means 5% of the traffic goes to the new service, and 95% goes over there. And then you can start setting up your CloudWatch alarms, which basically essentially says, if everything looks healthy, then scale up your version 1.1 and scale down your version 1.0. We also need changes to software delivery model, and that's the last part of my talk here. Jeff Bezos wrote in his 2018 letter to shareholders, he said that one thing I love about customers is that they're divinely discontent. Their expectations are never static, they always go up. At the end of the day, our goal is to deliver value to the customers, and customers are expecting at any point of time value, selection, and convenience from us. This 2018 State of DevOps report talks about, it takes multiple teams and divides them into low, medium, high, and elite categories. And elite is a new category that was added this year only. It talks about the difference between low and elite categories. The elite categories are deploying code more frequently. They are doing faster time from commit to deploy, and they have a lot faster recovery from failure. So the important part is to embrace the failure and be able to recover from it a lot more gracefully. So let's take a look at it, how we can achieve that. So in a typical monolith development lifecycle, you will have your developers, multiple teams working on this one big monolithic application, and they all have to go through this shared release pipeline, which can cause friction, as we talked about earlier. You have to have those merge Fridays to make sure that this all goes through smooth. With monolithic, with the microservices, the deployment model changes completely. You have these two pizza teams that are focusing on a particular service, and they have their own delivery pipelines. And then at the back end, you are having those services really collaborate with each other to generate a high-level application and deliver value to your customers. So how does Amazon do DevOps? Well, we talked about it. We decompose for agility, as opposed to one big application. It consists of thousands of microservices. We automate everything. We use the standardized tools, which makes it very easy for us to scale. And we also use infrastructure as a code. You can use CloudFormation, you can use Terraform, Chef, Puppet, whatever comes to your knowledge, all of that works. Several customers have gone through this journey with Amazon and with a lot of others as well. But one of the Amazon customers that I would like to highlight is McDonald's, how they have gone through digital transformation over the last couple of years. McDonald's is a restaurant which serves food, and we all get hungry 3 times a day. So on a given day, they're taking between 250 to 500,000 orders from 37,000 restaurants over 120 countries. That typically goes to 20,000 transactions per second. So McDonald's, in order to reach that scale, they partner with apps like Uber Eats and be able to deliver that value rather quickly. This is exactly where they use Amazon ECS to scale and build a microservices-based architecture over there. They were able to use CloudWatch alarms, auto-scaling groups, and task placement strategy to efficiently optimize their resources. With that, I will invite Sarah to talk about how they're using containerized microservices in Financial Times.
Thank you. So I'm here to talk about adopting microservices and containers at the Financial Times. Financial Times is one of the world's leading business news organizations. I'm talking specifically about the content, publishing, and delivery platform we have at the Financial Times. So this is a very simplified diagram of what that does. So effectively, we take content from various content management systems. So these are where journalists are writing stories. When they click publish, we get a notification, and we transform that content into a common format. We annotate it so that it goes through a natural language processing pipeline, so we can say this story is about Apple, or it mentions a particular person. To do that, we have to load a great number of concepts. We've got probably 14 million concepts of companies, people, and the relationships between them. And then we have a set of APIs that we use to provide all of this information to our customers, both internal and external. First step of so there's several steps in our progress through this. First step was to go from monolith to microservices. Microservices started to be a thing that people talked about in 2012, but it was really 2014 when it started to be a thing that people really got excited about. And the Sam Newman book came out in February 2015, but we were already looking at it in 2013. So we were pretty early adopters We started the process before any of these things were published. But in fact, we started working on the things that we needed to enable this a year or so earlier, because there are conditions for change. There are things you need in place if you're going to start building microservices. The thing about microservices, you have a lot of them. And as soon as you have a lot of things, you have to do things a lot of times. Every time you make a change, you've got to do it for every microservice. So as usual, XKCD nails this. Basically, if you're a monolith, you're somewhere up at the top right corner. So you can afford to do a manual process because you're probably only doing it a couple of times. But with microservices, you're doing things multiple times a day. That means you need to automate, because otherwise you're taking too long to do things manually. And the first example for us was about provisioning a server. And when I joined the FT in 2011, it took, on average, 120 days to provision a server. I like that. Oh my God. But basically, this was, we had to basically buy it, configure it, set it up. It was all manual. You can't do microservices when you have that kind of a process, because you're going to have lots of servers. And also, you do actually want all the servers to be the same. You want them to be cattle, not pets. So you need to automate it using templates. So the first thing we did was set up a team who built something called FT Platform. And it was an investment in automation of provisioning and deployment. Developers could set up a VM via self-service, and those VMs would have a useful scaffold of all the things that you need for a server, so things like monitoring, logging, deployment. And that launched early in 2012 using our own private cloud, and we started supporting deploying to Amazon in 2014. And the difference was massive. So basically, by 2014, we were taking minutes to deploy it. It's several orders of magnitude quicker. It's about 1/8 of 1% of the time that it took in 2011, and that's transformational. And you really can't start with microservices until you can provision a server in minutes. The same need for speed applies for deployments. If you're going to benefit from microservices, you need to be able to make lots of small deployments. They have to be quick, easy, which means they have to be automated. And you really need them to be zero downtime, because you need to be able to make them all the time without affecting your users. And when you build a new microservice, you want to be able to set up a deployment pipeline for it very quickly, because you're doing this all the time. And our old build and release process was very manual. We built one deployable artifact. We were using continuous integration. We were quite good at that, but the deployment was done manually. We did 12 releases a year, because we couldn't do a zero downtime deployment. And this is for the content publishing platform. And the thing about a news organization is you need to be able to break the news all the time. So you have to negotiate a time when you think it's very unlikely that anything's going to happen that's newsworthy. That's quite hard to do. So probably 12 releases a year, quite a few of which get cancelled at the last minute because some news event happens. And because we only did 12 releases a year, the process around each release was complicated and time-consuming. So this is the process we followed. So you'd batch up a bunch of stories, you'd cut a release, you'd do some testing, you'd test a rollback. It never worked. You'd test it again. And then basically you'd say, right, we're ready to go live with it. Worst of all, the actual release was done by someone logging onto the boxes and following some manual steps documented in a spreadsheet. This is 6 steps. There were actually 54 steps in this particular release spreadsheet, done by someone going through it. And they were never accurate. There are always typos. There's always things that's wrong. You're relying on the fact that the person doing it has the context to say, this is not what you meant me to do. And they took a long time. They often took longer than the downtime negotiated. We were making schema changes on a relational database, and things could go wrong. And when they did go wrong, it takes ages to work out exactly what's gone wrong when you've got 4 weeks' worth of work in that one release. I don't know if anyone's had to do a git bisect to try and work out where something went wrong, but it's not fun. So our new deployment pipelines were based on Jenkins and Puppet, and our FT platform would basically install Puppet for you as part of setting up a server. So it wasn't completely straightforward, but it was pretty quick, and it made a massive difference because it was automated. If you can't deploy the smallest possible change to production in under an hour, you should fix that first, because microservices are hard work in a lot of ways, and you need to be able to benefit from the work that you're doing, which means you need to be able to do continuous delivery with the smallest possible gap between starting work on something and seeing it live in production. Continuous delivery forces a change in your culture. It certainly did at the FT, because you need to persuade people to trust your teams, to remove process, to empower people. You know, you can't have a change approval board that meets on a Tuesday to decide to go to test on a Thursday if you want to do 20 releases a day. It just doesn't work. So you absolutely have to get people to trust that you are likely to release the things that don't break. So we got to the point where we could provision a server quickly, deploy quickly, and we started building microservices. We aimed for single responsibility. It's good. It's the right thing to do. But we had a surprising number of conversations about exactly what the right level of granularity is. I think actually it's quite difficult to get it right. As Arun said, asynchronous communication by queue is essential because you don't want a long chain of synchronous calls. It's a bit brittle, and it means that you're coupling these services together. They know about each other. You really want a service that generates an event to just do that, put it on a queue, and then other services can consume that are interested in it. And if you have a new service that is interested in that event, the originating service doesn't need to know about it. We have taken big advantage of the fact that we can have polyglot approach, and particularly with polyglot persistence. Because our services own particular parts of the data, we can store things in the correct database for that. So we store our articles in MongoDB because really it's a document, store it in a document store. But we also store the articles and annotations in a graph database because we want to be able to navigate that graph and find all the articles that are about Amazon. And then finally, we put all of that information also in Elasticsearch because we do need people to be able to discover our content. So we've got a bunch of different databases at play in our architecture. So what do we gain from moving to microservices? They're small, so they're easy to understand. If you're a developer picking up a service you've never looked at before, you've got a good chance of working out how it works. And we spend more time running and maintaining services than we do building them generally. So it makes sense to optimize for ease of understanding for someone picking it up. They have clear boundaries. We have HTTP calls, or you're reading off a queue. So that's easy to test because you can inspect the requests, you can inspect the responses, and you can mock out collaborating services. The releases are small, they're self-contained. You can look at the diff and work out what the change is. Generally, if they fail, you can fix the problem and roll forward very quickly. And we moved from 12 to more than 2,000 deployments a year because we could do zero downtime deployments. So I think it's about 200 times as much. You can do that kind of change to release more often with a monolith, but it's still quite hard to understand whether a particular change has effect somewhere else. With microservices, the very clear separation lets you think, yeah, this is pretty low risk. And the failure rate is much, much lower. So with our 12 releases a year, we'd have probably a couple that something went wrong. Now it's less than 1% where we have any kind of problems, and we fix it extremely quickly. And this is gone into in depth in the State of DevOps report that Arun talked about earlier. Decreasing the time to get new features out is the reason to do microservices. It's how you can sell the business on it. Because you can say, look, you can have an idea now, and we can see it live tomorrow, as opposed to in 6 weeks' time. And you need the business to be on side to do this kind of change. But there are challenges, because you remove the complexity within the services, but at the expense of vastly more complexity between services. It's a distributed system now, and lots of people are making changes on it, and you don't necessarily know exactly what it looks like at any point. We found a lot of problems around getting the right level of granularity on the microservices. And I think we probably went a little too granular. Because you don't want to have lots and lots of microservices because you just have to pay a tax every time you do something. What we've tended to notice is that sometimes you have lots of microservices that always get deployed at the same time, they always change at the same time. Suggests they might, in fact, be one microservice that you should combine. If you have one microservice that you find you'll have a lot of contention with people making changes to it, maybe it should split. And really, you should be prepared to change your mind on this. It's actually quite easy to do, so have a look. If you're having pain points, you just change it. Because we have multiple data stores and multiple regions, where we don't have necessarily a database that's clustered across regions, we have to deal with eventual consistency. There's not a single transaction anymore. And I actually think that's pretty a good thing to plan for. So you can have partial failure, partial success. We've published the article, but it hasn't made it into our Elasticsearch instance in the US. But we're lucky because we're doing something that's idempotent. So we can just republish that article, and as long as it makes it everywhere in the end, we're good. So we use business level monitoring a lot here. We have a microservice that checks that publish event went everywhere, and if it doesn't, there's an alert and we republish. The way that you develop is very different from monolith to microservices. You know, when I used to do monolithic development, you have a database, you have your app, you probably have a debugger, you're kind of trying to work out what's going on in the middle of your code. With microservices, you probably don't have the whole of your microservice architecture running locally. I don't think you should. You really want to look at the testing at the boundaries. One thing I think is useful is if you've got a microservice that reads off a queue, is to put a small adapter in there that means you can exercise it by sending in an HTTP request. It just makes testing a lot easier. I'm going to say that, in contrast to what Aaron was saying earlier, I think repeating yourself can be a good idea with microservices. And basically, because you need to be careful about what you extract into a library. So we've had great success where we've extracted behavior into a library. So for example, converting errors in the code into HTTP status codes, or adding a transaction ID across services. We've built these libraries, we never change them. They're used in all of our code, and that's very successful. Where we've really failed is where we tried to extract some idea of a common model of what an article looks like, because we found that every time we changed that model, we had to release a bunch of microservices, and anytime you're releasing all your microservices together, you've just got a distributed monolith, which is the worst of all worlds. So what we found is instead of having some strict model, we were better off having every service be lenient in what it accepted. Look for the fields it cares about, ignore all the rest. And if you have a lot of services that care about exactly the same fields, maybe they're not separate microservices. Maybe they have the same domain. There's a lot of operational complexity. When you have a monolith, you probably have 2 application servers. You monitor the CPU disk space. You can hop on the boxes and tail logs if you need to, but you can't do that with microservices. You can't have one team writing code, the other team deploying and operating it. Things change too often. You can't afford to do handover when you're writing a couple of new services a week. And gray failure is the norm. So you've got a distributed system with many, many services. There's no in-process communication, it's all over the network. So things go wrong. But if you've architected it right, it's resilient and it recovers. So if you don't change the way that you do monitoring, you're in trouble here. So we have 150 services. If we have 2 instances in 2 regions, 5 checks every minute, we've got over 4 million checks a day, and what that means is that a 1 in a million event happens 4 times a day. So transient failures happen all the time, and lots of these failures are things that you don't care about. So if I have a service that calls out to another service and the first attempt fails and it retries and that's successful, I don't really want an alert for that first failure because the thing I wanted to achieve worked, it was fine. So you need to monitor for the event that you care about. You need to think about what would you want someone to call you about at 2 a.m. And I'm absolutely certain I don't want to know that something succeeded, but there was a bit of a retry in the middle. And we care that our articles get published. So we're basically looking to see, did that article successfully get published? Your event of interest in a microservice is spread over huge numbers of VMs. It's hard to even know which ones. So you absolutely need to do log aggregation. Send all your logs to somewhere central where you can ask questions to your logs. It's a very good idea to have these logs be structured, because when you want to ask a question in key-value pairs, make it a lot easier. Tracing is also important. How do you tie together the fact that all these logs represent the same event? I can go into our log aggregator and say, okay, here are all the logs. There's probably 25 logs. We do it via transaction IDs. We've got a library in the 2 main languages we use, which is Java and Go, that looks for an X request ID header. And if it's there, takes the value and puts it on every log message, on every call out to another service, on any message that it sends on a queue. And if it's not there, it generates an ID and adds that. So this is something that every service has. And we don't have any problems where people don't add it because A, we've got libraries, and B, it's so useful. Anytime you want to work out what's going on, this is really important. Now, we did this years ago. If we were starting now, we wouldn't build this ourselves. We'd use something like Zipkin, some open tracing, or benefit from something that a service mesh would give us. But we have it in place, so we kind of stick with it. In contrast to Arun, I think microservices can be expensive to run. It kind of depends what your approach is. So we don't have spiky payload where we need to scale up some part of our flow. And if we go from having a monolith on a single VM to having 150 microservices, even on the smallest VMs, that's going to be more expensive. But you need to compare that increase in costs against the benefits of being able to experiment quickly, not having to pay overtime for people to come in at the weekend to support releases. So when we started out on our private cloud, it's quite hard to attribute costs, but with AWS, we've got that. We've got our own AWS account within the organization, so we can see where our costs are high, and we can make changes for that. Any manual change has to be done many times. So we need to migrate from one version of Circle CI to another version for continuous integration. That can be a time-consuming thing if you've got 150 services. So things like provisioning, even with our investment in provisioning, we'd have 8 VMs because we'd have 2 in it, 2 of 2 production regions, a couple of staging, a couple in development. And even if it takes minutes, that starts to add up to quite a long time. Automation and abstraction save you on this. So you basically want to make a change to one thing and have it reflected automatically in all the services. So a templated deployment pipeline can make a massive difference. So that was our first step, was to move to microservices. But after a while, we started looking at the cost and at the overhead of provisioning and setting up deployment pipelines for a new service. And we started to get interested in what containers could give us. So Docker was released in March 2013. And the first enterprise-ready release came out in October 2014. And air quotes, because I don't think it was enterprise-ready. It was ambitious. We were already looking at containers at this point, so we were very much early adopters. This is a great blog post from Dan McKinley, who at the time was working at Etsy. I really recommend reading it. Talks about innovation and says, well, you can't do innovation everywhere at the same time. So you need to pick what the things are that you're going to innovate on. Think about the fact that you have a couple of tokens. What are you spending them on? So maybe you adopt a new database that's never been used before. Well, that's an innovation token. Maybe you're using a new programming language, same thing. In 2014, writing the cluster orchestration was definitely spending an innovation token, but it was worth it for us because we thought the cost saving and the time saving of moving to containers would make it worthwhile. So we built our own container platform on CoreOS because it's a cut down Linux distribution designed from the ground up to manage deployment of Docker containers. We built a lot of other things ourselves. We were running using systemd as a service manager, defining service files, and then systemd would run the service. Fleet is a cluster manager that manages that at a cluster level. We wrote our own routing using vulkand, which is a programmatic load balancer, and storing the configuration for that in etcd, which is a key value store. We wrote a service that would take human-readable, human-maintainable configuration and convert it into vulkand config, which isn't particularly readable. So this is just an example of the kind of file that we had. It's basically saying, what other services do we need? How do we start it? How do we stop it? And our deployment was based on a YAML file in Git that defined all the services that we wanted to run, including their sidekicks, how many instances, and what version. And we had a Go service that just looked at this file, looked for changes, and then made the environment match whatever was in the latest version of the file. So deployment to production was a Git merge onto master. By mid-2015, we were running this in production. So we started by building new stuff there, and then we migrated everything else across to it. So what did we gain from doing this? Well, we could run multiple services on each VM, which we couldn't do with our previous stack. So we ended up running our services on 8 extremely large VMs per region rather than 300. And that was about a 40% reduction in AWS costs, which was worthwhile for us. And it was many fewer steps to start running a new service in production. You didn't need to provision a VM. You didn't need to set up a deployment pipeline. You just needed to edit a YAML file. Containers gave us the fact that development, staging, and production were the same. So you don't have any issues where the version of Java in one is different from the version somewhere else. But it came with challenges. And most of this is because we adopted it so early. We had to build quite a lot of stuff ourselves. And when you do that, that's kind of painful. So supportability of something you build yourself is a problem because you have nowhere else to go for help. Documentation, in particular of decisions people made and why, is very rarely a priority. And in our case, most of the containerization work was done by a small group of developers who all left the FT within a few months in 2016. So when that happens, you've got something you're supporting that you don't really understand deeply. And I think every time you build something yourself, you have something that in 3 years' time people will look at going, well, who knows how that works? And we had technical debt. And this is true technical debt, the idea that you consciously accept something that's not quite optimum because you know that you get some benefit from it. But eventually, the interest on that technical debt starts to hurt you. And our routing was complex and error-prone. People would try to add new routes into our stack, and they'd often get it wrong. And when that happened, they quite often broke all the rest of the routing too. And there was limited rebalancing of services. So if we lost a VM, we were OK, because Fleet would move all of those services to a different VM. But it wouldn't, we didn't get restarting of that VM. We didn't rebalance those containers. And by late 2016, we were feeling the pain, but we were also looking out and seeing that tools were maturing. So when we started using containers, we didn't have a lot of options for cluster management. But now we could look around and see people successfully using cluster orchestrators in production. And this is the flip side of innovation tokens. you should choose boring technology. Boring doesn't mean bad. Boring technologies are things lots of people use successfully, letting them focus on things that are differentiators for their company. And new and innovative technology is exciting, but the capabilities are not necessarily well understood. In particular, failure modes are probably not well understood. And you say you want boring in software that you're operating. At the FT, we often work at the leading edge of technology. You can get a lot of benefits from doing that, but sometimes that means that you need to change your stack or revisit your decisions because you tried something innovative and it didn't work, or because the area's matured and now you can buy something in that gives you the same benefits as the thing you've been building and maintaining. And you shouldn't be too scared of making the wrong decision. So Jeff Bezos says there are two types of decision. Type 1 is not reversible. You should be very careful about making them. But type 2 is like walking through a door. You can always go back. Arun says they call it like a one-way door, two-way door thing internally at AWS. The danger is that people use the heavyweight decision-making process that you need for a type 1 decision for everything. So we built our own container stack because it was the right thing to do, but now we've moved to another stack because it seems like the right thing now and it's ready for us. So end of 2016, we started looking to migrate away from our hand-rolled platform. We had a workshop, evaluated a few options, and we selected Kubernetes. So Kubernetes was released in June 2014, and the 1.6 release in March 2017 was viewed as a stabilization release, i.e. this is ready for prime time. And by August, people like GitHub were migrating, so that suggests that people trust that it's now ready for production use. So we started looking at it early in 2017. Again, this is pretty early adoption. And it solved our biggest issues. I mean, there's a ton of stuff that Kubernetes gives you. I'm only really talking about the things where we noticed the difference. So it assigns names to every service, so routing was simpler and much less error-prone. It's self-healing. Unhealthy instances get restarted, so you don't have to spend a lot of time yourself doing this. And it moves services around based on CPU or memory load, so you don't get some really unbalanced set of services. We changed our deployment mechanism at the same time. Part of it was just a simple swap of systemd service files to Helm charts. That was very straightforward. And part of it was that we actually introduced a templated Jenkins pipeline. And this is because although the Git-based deployment was simple, in theory, it wasn't so simple in practice. First of all, people found they had Git merge issues surprisingly often, but actually the worst thing was when you wanted to do a small change, you ended up pulling in all of the changes anyone else had made to production and then having to fix them up. People just wanted to deploy their service. But it's still a very simple deployment mechanism. Everything on the yellow background is automatic. So basically, there's not much that we have to do. We're just doing testing, verification, then saying, yep, good to go. So by February this year, we were live on Kubernetes. So the whole migration took us around a year, which actually stacks up very well with what I hear from other people doing this. It just takes time to do this. And we were slower than we could have been because we didn't staff it very highly. It's very hard to convince product and business that you want to spend a lot of your money and effort for a year moving from one container stack to another. So we probably didn't get as many people as we should have done to do that. And this is a key point, which is that actually moving around takes time, requires investment, and you need to be able to sell that to your business. So the business may suspect that this is just resume-driven development. Oh yeah, you're now introducing Kubernetes. But actually you can sell things like, you will do 200 times the number of releases that you do currently, or the costs will go down by 40%, or we'll be able to attract and keep technical talent because we're using something that is state-of-the-art. And you can probably build a roadmap that gives value along the way. It's a way to keep getting funding for the work that you know you need to do. So what do we gain from this move? It was a great success for us. It's considerably more stable. And when things go wrong, normally it heals itself. It's much easier to support. We can look things up. We can go to training courses. This is a thing that other people use. But there's still challenges. So we're happy compared with what we had before. But you still have a platform you're maintaining if you're running on Kubernetes. And if you're a development team and not a platform team, that's quite a bit of work. We had a lot of experience, so we were able to adopt that. But for other teams, a pattern I see working is to have a central team providing that platform. So the delivery teams can just deploy the stuff they want to run without worrying about the gory details. So now what? Are we stopping at this point? Are we happy? Well, containers are definitely one of the things we want to use at the FT. We also do things like deploy apps to Heroku. We have quite a lot of serverless. But most of our deployments to EC2, we use containers. It's part of our technical strategy. But we don't have a common approach. We've got people using Kubernetes. In fact, we have 2 different teams using slightly different stacks. We have people on ECS, Elastic Beanstalk. So we kind of think maybe the thing to do is build one container deployment platform now, so every team doesn't have to build and run their own. But really, I think what we want to do is make it someone else's problem. So looking at EKS, Fargate, we want to not have to do any operational stuff, just run the workloads. But in summary, for me, what this has taught me is you need to get comfortable with change. I think change is coming quicker and quicker. You can benefit a great deal if you're willing to change and adopt new things. It gives you an advantage. You get good savings, or you get to move much more quickly. It's been worth it for us, but it requires a culture change to accept that these things are always going to change. And that's it for me. Thank you.